When we think of Cold War bunkers, images of steel doors, reinforced concrete, and thick, imposing walls immediately spring to mind. Yet, beneath the surface, another crucial material often played an unsung role: wood. Not just any wood, but beams engineered and treated to withstand the silent, relentless threat of underground decay. For decades, these wooden structures resisted moisture, fungi, and even the subtle pressures of shifting earth. Today, we're going to explore how engineers achieved this, drawing on centuries of ancient wood preservation techniques, and how you can apply these insights to modern survival structures or historical restoration projects. The first secret of durable underground beams is that engineers didn't reinvent the wheel. They borrowed from the ancients. Cultures around the world have been using wood in wet or buried environments for thousands of years. The Egyptians, for example, knew how to treat timbers for use in canals and temples, while European builders perfected the art of waterlogged pile foundations. By studying these methods, Cold War engineers could anticipate the threats that buried wood would face and preemptively counter them. One technique was to select naturally rot-resistant species like oak larch or chestnut, known for their dense resinous fibres. By pairing these species with modern chemical treatments, bunkers achieved a level of longevity that few would expect underground. Moisture is, well, the invisible enemy of buried wood. Even tiny amounts can catalyze fungal growth, rot, and, structural weakness. Engineers tackled this in multiple ways. First, they focused on drainage. The foundation and floor systems of bunkers were designed to channel water away from wooden supports. Then, the beams themselves were often treated with oils, tar, or specialized preservatives that penetrated deeply into the fibers, creating a barrier against dampness. For anyone looking to apply this knowledge today, the lesson is clear. Never underestimate the role of moisture management. In practical terms, if you're constructing a root cellar, a small underground shelter, or even a raised garden bed, start by ensuring water has an escape route and consider using treated, rot-resistant wood for any buried supports. Another subtle yet critical factor is ventilation. You see, buried spaces are really prone to stagnant air, which in turn just amplifies those pesky moisture problems. So, engineers integrated ventilation shafts, air gaps, and even passive airflow systems to keep underground timber from stagnating. This principle is directly applicable today. Even small shelters, benefit from channels that allow air to circulate around wooden supports. For instance, placing a layer of gravel beneath wooden beams or using vented enclosures reduces the risk of slow decay by letting air move naturally and carry moisture away from the wood. Cold War-era engineers combined traditional knowledge with mid-20th century chemistry. Some beams were soaked in preservative solutions containing creosote, copper compounds, or other antifungal agents, while others were baked or kiln-dried to remove residual moisture. Interestingly, the methods echo historical approaches. The Vikings soaked wood in tar, and Japanese builders treated beams with natural oils for centuries. Modern survivalists or historical restorers, they can experiment with similar methods on a smaller scale. Soaking beams in linseed oil, for example, or applying borate-based preservatives can make your wood last decades, even in contact with soil. Engineers also understood that decay wasn't the only threat. Mechanical stress mattered too. By placing beams in compression rather than tension, ensuring proper support spacing, and avoiding contact with acidic soils, they significantly extended the life of their structures. If you're planning any underground project today, you know it's really important to consider the placement of your beams carefully. Use stone or concrete bases where beams meet the soil, avoid uneven load distribution, and, rotate structural elements to minimize long-term strain. Small adjustments like these can, honestly, prevent premature failure. This knowledge isn't just historical trivia. It can actually be applied in practical ways. If you're building an underground workshop, storm shelter, or, say, a long-term root cellar, choosing the right species of wood, treating it with natural oils or modern preservatives, and managing moisture and airflow can give your structure decades of resilience. Even above-ground applications, such as raised decks or, garden trellises, benefit from the same principles. Use dense, rot-resistant wood, treat it to repel moisture, and avoid direct soil contact whenever possible. Understanding how engineers made wooden beams last underground is, honestly, a window into human ingenuity, bridging ancient knowledge with mid-20th century innovation. It's a lesson in observation, adaptation, and foresight. For history buffs, it enriches our understanding of Cold War engineering. And for survival enthusiasts, it offers, concrete strategies for building lasting structures with limited resources. By studying these methods, we not only preserve the past, but also create solutions that endure into the future. If you found this guide valuable, consider subscribing to Thermal Vault for more in-depth explorations of historical engineering, survival techniques, and practical applications. Share this video with fellow enthusiasts who appreciate the art of longevity in structures, and, of course, keep the knowledge alive.